Welcome. Please be sure that you have read the lab manual before proceeding to watch this video. Thank you. Welcome to Lab 1. In this lab we will be tracking a small metal ball as it travels through the air. And from this tracking we'll be able to calculate a value for g as well as look at what happens when it moves in a horizontal direction.
Let's start by assuming that the acceleration on an object is constant. Once we make this statement, this equation is true about the velocity of an object. This is the equation of a straight line. If we were to measure the velocity over time, we would get points that would line up into a straight line. Our assumption also gives us the position. If we were to plot the position as time passes, we would get a line that looks like a second-order polynomial because of this equation. Let's start the experiment. The first thing you'll need to do is to change the settings on the webcam software. First, make sure that video input and capture controls are turned on. You'll want to capture at the highest resolution. You'll also want to go and check your settings. Color settings should stay about the same. However, for image settings, you'll want to turn the saturation all the way down. We don't really need color. You'll also want to turn all the other things up to keep the shutter snapping pictures as quickly as possible. This will keep the ball from blurring. The frame rate will remain at 30 frames per second. The final value can be adjusted to match your lighting situation. You'll need something between 100 and 200 to get a clear picture. We are only interested in vertical motion for the first experiment. While it might be nice just to drop the ball and watch it as it goes down, we won't get enough data if we do this. So instead, we will drop or slightly throw the ball downward. When the ball hits the table, its acceleration will not be constant. Our equations will not work. So we must look at the ball after it hits the table and once it is again in free flight. Using the video from the webcam, we can track the locations of the ball at every frame. Use the arrow keys to switch between frames, and record the locations onto the graph paper in your lab manual. Try to estimate the center locations as accurately as possible. Can you estimate the uncertainty of these measurements? Think about which step you make the largest guess in. All measurements should be made with a ruler, not just by guessing squares. The midpoint times and the midpoint velocities are calculated from each pair of points. Notice that you lose 1 point when you do this. When you calculate acceleration, you will again lose 1 point. Take the average of these values for a table. All the rest of the calculated values at the bottom of this page come from the graph, or calculations from the graph. After lab, you will make an Excel graph that looks something like this. You should use the Excel scatter plot. Do not connect the lines. Use Excel's trend line feature to find the best fit. Make sure that you display the equation on the graph. Make sure you also include a title, labels, and units. Feel free to be creative about other aspects of the graph. Part 2 of the experiment is similar. However, now we will be looking at both horizontal and vertical motion. You will want the ball to arc across the graph paper. Try throwing the ball at the left corner of the board and expect it to bounce at the right corner. You can use your gray box to stop it from rolling around the room. When you record these, you will need to pay attention to both the X and the Y directions. While the origin of your graph can be anywhere, I would recommend measuring from the bottom left corner. This time, there will not be a velocity graph or velocity calculations. Be careful when you make your fit lines to these graphs. Think about what you're trying to measure. Let's look at a possible source of systematic error. Here is a side view of the webcam viewing the ball. The first red line on the left is the actual distance moved. The red line on the right is the distance we record. What effect do you think this has on our result? Remember to return the gray box and its contents when you're done.